Hello, dear students. Today, inshallah, we will talk about the state of matter. State of matter. State of matter. What is meant by state of matter? Okay. First of all, we must know what is meant by the matter. What is the matter? The matter, everything has a mass and occupy a volume. This is what meant by matter. Matter everything has a mass and occupy volume, has a volume, such as the stone. The stone, as example, is a matter. My cellular phone, mobile, is a matter because it has a mass and occupy a volume. I am as human being is a matter because I have mass and occupy volume. So, what are the states of matter? States of matter. Matter has three states. Matter has three states called states of matter. States of matter. Which is solid state? Yes. Liquid state. This is one of the states of matter. And gas state. Gas, liquid, solid. What is the difference between these three states of matter? This is the main question now. What is the difference between these three states of matter? What is the difference between solid, liquid, gas? Okay, we said before that matter has a mass and occupy a volume. Yes. The states of matter, in those three states, the difference between them, which is what is control the state of matter? What is the difference between solid state, liquid state, gas state? As example, water. All of us know water. Water. The water has three states, which is solid, ice, liquid, water, normal water, which we are drink, and gas state, which is vapor state for the water, called gas state. The question now, what is the difference between these three states of matter? Okay. Come with me to see the difference between them. We can see that the difference between the three states of matter is, number one, the forces of attraction. The forces of attraction between the particles of the matter. The forces of attraction between the particles of the matter. The forces of attraction, again, between the particles of the matter. The forces of attraction between the particles of the matter. Number two, these forces of attraction between the particles of the matter called intermolecular forces. Don't forget this expression, please. Intermolecular forces. Intermolecular forces, which is the forces of attraction between the particles of the matter. Okay. Number two, which is the distance between the particles. The distance between the particles in each state. The distance between the particles called intermolecular distance. The distance between the particles called intermolecular distance. Intermolecular distance. Okay? Those two factors, the factors which control the type of the matter or the state of the matter, solid, liquid, or gas. However, come to see. As example, this is a solid state of matter. These are the particles of solid, such as whatever solid ice, whatever iron atoms, whatever calcium atoms, and so on. Those are in the solid state. All of them are packed, very closely packed together. And they have very regular structure in the solid state. The particles rearranged beside each other in an regular form. In a regular form like this. This is the solid state of matter. The particles rearranged beside themselves like this. This is solid state of matter. What about the forces between these molecules? It's very strong forces. Look, very strong forces between the molecules. So they are packed together. Nothing can pass through the solid state. Why? Because these attraction forces between the molecules is very strong attraction forces. What about the distance between these molecules? Very, very small distance. So the force of attraction, like this, very strong forces of attraction. What about the distance between these molecules? It's very, very small distance. Very, very small distance. So what about the liquid state? The forces between the liquid state, of course, weaker than that of the solid state. So the liquid molecules are in random rearranged. Why? Because they slide over each other. Why they can slide over each other? Because the forces between them is very weak. So they can rearrange in some way like this. This is liquid state. What about the gas state? Of course, this is a gas state, and this is a gas state like this. Oh, there is no any force between the gas state molecules. No force, absolutely. Science says that the forces between the molecules approximately zero. There is no force. It is neglected. So the force in case of solid is very strong. Distance is very, very small. In liquid, the force becomes to decrease. The force decreases and the distance start to increase. What about the gas state? The force is very neglected like this. What about the distance? It is very large like this. Large distance. So the two forces always opposite. As the forces increases, the distance decreases. And as the forces decreases, the distance increases. So We can convert from solid state to liquid state. How this takes place? By heating. Why? Because on heating, we can break down the forces between the molecules. When we heat the solid state, the particles which is in fixed position like this starts to gain heat. This heat go to the molecules. So the heat enter to the solid state, which is called endothermic process, because the molecules can gain this heat. يبقى المولكيولز or the particles gains energy, okay? Gain energy. And so the forces between the molecules start to decrease and the distance start to increase. يبقى what is the role? What is the function of this energy? This energy can break down the forces between the molecules like this, can break the forces. So the molecules starts to go far apart from each other somewhat. So the solid turns into liquid. What about the forces in the liquid state? It becomes smaller than the solid. It is present, yes, but smaller like this. And look to the distance, start to increase. Okay, what about extra heat to the liquid state? Extra heat. When the liquid state gains heat, it start to start to what? Start to convert into gas. Why? Because this heat gained by the molecules make the molecules vibrate more and more. The molecules vibrate more and more and go far apart from each other. So what about this heat? The molecules gain energy. The molecules gain energy. So their kinetic energy increases. The kinetic energy of molecules increases. So forces between them decreases. So distance increases. Okay. When the liquid state gains extra heat, the kinetic energy start to increase more and more. Start to increase more and more. And the forces decrease more and more. And the distance increase. So there is relationship between the energy and the distance. As the energy increases, the distance increases like this. This is called the kinetic theory of particles. When they gained heat, gaining heat called endothermic process. So this process called melting. So melting is endothermic process. Endo, which means that heat takes in by the molecules, called melting. Melting, endothermic, endothermic process. Endo means in. Thermic means heat. Heat taken in by the molecules. Their kinetic energy increases and the distance between the molecules decreases. Sorry, the distance increases. The forces decreases. The forces decreases like this. The distance increases. So the solid converted into liquid. What about the liquid when it gains energy? The same. The kinetic energy increases more and more. So the forces decreases more and more and the distance increases more and more. And this is called boiling. Boiling. Boiling, endothermic process. Endothermic process. Good. This is called the kinetic theory of molecules during heating. These molecules go far apart from each other, the gas molecules, and the forces between them, they are very neglected. They are very neglected forces. What about the distance? Very large. Okay, come to make vice versa. How it comes? We can cool down these gas molecules. When they are cooled down, we can they gives out energy from them. When they cool down, they turns into liquid. And when the liquid cool down, it turns into solid. The cool down is the reverse of heating. What happens during cooling down? Cooling down. What happens during cooling down? They lose energy. The molecules lose energy. What about the kinetic energy? Decreases. Decreases. What about the force? Increases. What about the distance? Distance decreases. This is called exothermic because the molecules give out heat. The molecules gives out heat and cool down so they can approach from each other again. They approach, cool down, cool down, cool, be quiet, quiet, cool down. This is called endothermic or exothermic. Bravo, exothermic process because heat is evolved from the molecule. Exothermic process. So cooling down called condensation. What is the meaning of condensation? Condense when something approach from each other called condense together. Condense comes from density, dense, more dense, which means come close together. So this process is called condensation. Condensation. This process called condensation. Condensation. What about extra cooling? When we cool the molecules more and more and more by putting this liquid in the freezer, what happens? These molecules loses heat. Again, yes, loses heat, loses heat, and cool down and come approach again and again and again, which is exothermic also, yes. This cooling down again, yes, cooling down. So the molecules lose energy again. So their kinetic energy decreases, decreases, decreases. And the forces increases and the distance decreases so we can get the solid state. This is called freezing. This is called freezing. This is called freezing. This is called freezing. Freezing. Okay? Called what? Called freezing. Okay? This is called melting, which is endothermic, boiling, endothermic, cooling down, condensation, exothermic, cooling down, freezing, exothermic. Okay, this process is exothermic and this is also exothermic. Exothermic process. Okay, come to the notes to see what is meant by these, by all of these. Number one, come to see what about the differences between the solid state, liquid state, and gas state. Okay, this moves very well. Okay. What is the main difference? Like you see, the main difference is here, the first thing, or the forces between molecules. In the solid state, the force is very strong. Yes, we said that. The forces is very strong in the solid state. What about the liquid? The forces is very weak. What about the gas state? Very, very weak. What about the distance between the molecules? The distance. In the solid state, the distance is very small. In the gas state, the distance is very large. Okay. What about the arrangement in molecules? In the solid state, they are close together in a regular arrangement. In the solid state, they are close in regular arrangement. In the liquid state, close together in an irregular arrangement, randomly distributed. What about in the gas state? They are free moving rapidly everywhere because the forces approximately equal zero. No forces to touch each other, to catch each other. What is the volume of the solid state? Has fixed volume. The volume of the solid not change. What about the liquid? Fixed volume for the liquid. What about the gas? Take the volume of the container. Has no definite volume. What about the shape of the solid? Has fixed shape, of course. What about your cellular phone? Is the shape of your cellular change with time? No, it has a fixed shape. Liquid, shape of the container. Gas, no definite shape. What about the movement of the solid state? They cannot move because they attach to each other. They move in its position. The movement vibrate and rotate about fixed positions. What about the liquid state? Move around slowly and slide over each other. What about the gas state? Move rapidly everywhere. So, since here there is no distance between the solid, so solid cannot be compressed. When you compress them together, pressure by pressing them, they cannot be pressed because there is no distance to be pressed. What about the liquid? The same. There is no distance. Distance very small. What about the gas? The gas can be compressed because these molecules can approach beside each other. So pressure always accompanied by cooling. Because of cooling make the vibration of these molecules is very small vibration. So they can approach to each other. What about matter conversion? We said that from solid to liquid by heating, from liquid to gas by heating, from solid to liquid called melting. Here is called melting. And from liquid to gas called evaporation. What about from gas to liquid? From gas to liquid called condensation, and from liquid to solid called freezing. When we heat a solid, its particles gain energy. This is what I said. And vibrate more quickly, like their kinetic energy increases. So the force of attraction of the particles becomes too weak. The forces decreases to hold the particles together so the solid melt. What about boiling? The same. Heating to higher temperature weakens the forces of attraction further. The particles lose any order and become completely free. Become completely free to form a gas or vapor. Then the liquid turns into gas, which is called boiling. Boiling. Melting and boiling are an endothermic process, which means they can absorb heat. Okay. Okay. We are going to say the difference between evaporation and boiling. What is the difference between evaporation and boiling? We can see something like this. Evaporation and boiling. Okay, what is the difference between evaporation and boiling? Here is a table like this. and there is a glass sheet is put on this table, glass sheet like this. When we pour some water on the table, some water, we pour them on the table here. After a few hours, these particles of water can evaporate. This is called evaporation. Evaporation takes place at any temperature, starting from 1 degree Celsius, even 99 degrees Celsius. The evaporation can take place at any temperature between 1 and 99. What about boiling? No, the boiling starts at 100. Starts at 100, exactly 100. The boiling starts at 100, not less than 100. This container full of water, when we heat this container to 100, it starts to boil. The boiling starts from 100. This is a flame like this, and the water boils, gains heat, the kinetic energy increases, comes far apart from each other, their kinetic energy increases, and the molecules of the water inside this starts to go up. From everywhere, the molecules go up here. And what about the molecules here? Go up again. This is boiling. What about if we have a container of water like this, and the temperature is less than 100? Let it 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius, 4 and 5 and so on. The particles on the surface only starts to evaporate. The particles on the surface only start to evaporate. Not the particles down here, no. The particles on the surface only starts to evaporate. This is called evaporation. Evaporation. Evaporation takes place in the molecules at the surface only, while boiling takes place in all the molecules inside and on the surface. All these molecules start to boil, to escape out. This is very rapidly takes place. This is very rapidly takes place. This is very rapidly takes place. ده بيحدث بسرعة جدا جدا. يعني البويلنج بيحصل بسرعة جدا. البويلنج takes place very rapidly. إنما evaporation very slowly. Evaporation, the molecules at the surface. Boiling, the molecules everywhere. The boiling must be 100 degrees Celsius or more than 100, okay, but not less than 100. While the evaporation at any temperature from 1 to 99. Okay, this is the main difference between boiling and evaporation. Changes in the 3 states of matter like this, from solid into liquid, called melting. Melting, yes, melting. Good. What about conversion from liquid to gas, called evaporation? Okay, evaporation. And this is from solid to liquid, melting. This is endothermic. Don't forget this. Endothermic. Which means that the molecules needs to absorb heat, to take in heat. And evaporation also endothermic. What about from the gas state to the liquid state, called condensing or liquefying? And this is exothermic. What about from liquid to solid? Exothermic, and called solidifying or freezing. Look, he says that in solid state, molecules held in fixed pattern but vibrating. Held by what? Forces, very strong forces. Bravo. What about the liquid? molecules packed close together in a random fashion, free to move. Why? Because these forces has been decreases. Bravo. What about the gas? Molecules widely separated move at great speed. Why? Because the forces becomes neglected. Very good. Very good. What about the particles and the diffusion? What is meant by diffusion? Diffusion, it is very excellent behavior for the particles. How it comes? What is meant by diffusion? Okay, look with me. What is meant by diffusion? It's very simple to know something like this. Okay, we start with matter. Matter has a mass and volume. The matter has three states, which is solid, liquid, gas, such as the water, solid, which is ice, liquid, like the drinking water as example, and gas like the vapor, we can see it during the boiling, making tea or something like this. States of matter, which is the four states of matter, solid, liquid, gas. What is the forces and what is the factors control the states of matter? Number one, the forces of attraction between the particles of the matter, which is called intermolecular forces, and the distance between the particles, which called intermolecular distance. They are opposite to each other. Take care, okay? When the forces increases, we said that before. When the forces increases, the distance decreases. And when the forces decreases, the distance increases. Okay, this is page number one. Page number two, the conversion and the kinetic theory, which make us understand why the solid becomes liquid on heating and why the liquid becomes gas on heating. This is called melting, and this is called evaporation, and vice versa. From the gas state to the liquid state called condensing or condensation, and from liquid state to the solid state called freezing. Yes. This is the difference between evaporation and boiling. Evaporation, escaping of the water molecules from the solid surface, but the molecules at the surface only evaporate, while the molecules inside, no, it stays here waiting for those will evaporate. The layer after it will evaporate and so on. So evaporation takes time, takes more time. While boiling, it's very rapidly. This is slowly takes place. Slowly takes place. Why? Because the molecules layer after layer can escape. While here, all the layers can escape at the same time. So boiling is very rapidly, okay? When you put something solid like here, such as egg, as example, eggs, you can hear the voice of eggs colliding each other. Why? Because the molecules here can move everywhere because it gains energy. The kinetic energy increases, make the eggs stick each other and strike each other, making sound, bloom, 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 like this. Okay. Okay. What about diffusion? It is so simple to know that the diffusion is diffusion. Diffusion comes from the word diffuse. So we say diffusion. The process itself called diffusion. The verb diffuse and the noun diffusion. Okay, what is meant by diffusion? Take care, please. Say this is a bottle of perfume. As example, bottle of perfume. has very excellent smell. Okay, like cube as example, has very excellent smell. Okay, its color is something like purple, dark purple. This is the molecules of the perfume inside the glass. Okay, it's closed. We can smell it? No. Why? Because we can smell only the particles of the air. This is the particles of the air everywhere. Okay, of course, this is the particles of the air. This is air particles. Okay, and this is the perfume particles. Perfume particles called P, perfume, okay? P particles, perfume. And this is the air particles called A. What happens when the atomizer works? When we push this atomizer, these particles pushed out and it will be here. We can see the vapor of the perfume. Okay, this is the particles of the perfume. If someone stands here, now can he smell the odor of perfume? No. Why? Because the perfume is still in this position and not reach his nose yet. What about this one? Has a big nose. Yes. This is someone like me. Has a big nose. Yes. This is the perfume particles. Yes. They are collected here. Yes. Is this one, which is called Hakim as example. He can smell. Now, this perfume, no. After some times, what happens to these molecules? They start to spread out, colloiding the air particles. When these particles colloid the air particles, it goes something like this. And colloid this and go here. And colloid this going here. And colloid this, and all the perfume particles starts to colloid the air particles. And at this time, the particles of perfume starts to fill all the room. To fill all the room. It takes some seconds, some minutes. It is spread out through the room by colliding the air particles. When it collides the air particles, elastic collision takes place. It escapes in this direction. And another one, colloid the air particles, escape to this direction. Colloiding this air and so on. Then this man can smell the odor of perfume. This is called diffusion. What is meant by diffusion now? Diffusion is the spreading out of particles everywhere. Everywhere until the different particles, air like air and perfume as example, until the different particles becomes uniformly distributed. Uniformly distributed. Spreading out of particles, yes, the perfume particles spread out like this. تنتشر في كل مكان. Spread out, تنتشر في كل مكان. ليه؟ لأنها كولويد بتصطدم بدي. لما كولويدنج، الكولويدنج ده اسمه elastic collision. وبالتالي go everywhere. Colliding each other, spreading out of the particles everywhere until the different particles become uniformly distributed. Here is more concentrated perfume, and here is the air. After 1 minute, they becomes uniformly distributed. The perfume particle here is more concentrated, and the air here is less concentrated. After 1 minute, all of them becomes uniformly distributed. So the perfume particles go from the more concentration area to the less concentration area. This is called diffusion. Look with me, please, what's meant by diffusion. Diffusion. Diffusion is the random movement of particles of liquid or gases. Of course, why we don't say solids? Because solids cannot diffuse. As the solid particles stay in their positions, cannot move, so they can diffuse. Of course, random movement of particles of liquids or gases, so they spread out everywhere. You can see bromine here, bromine gas, which is brown in color. And if there is a paper between these two glasses, two gas jars, there is a paper between them, separate between them. When we remove this paper, the iodine gas start or bromine gas starts to diffuse. Here is air particles. When the particles of this halogen starts to diffuse with this air, they collide with each other. They becomes uniformly distributed like this. They become uniformly distributed like this. The random movement of different particles like perfume and air, so they get mixed up together until the mixture becomes uniform. Uniform have the same rearrangement, is called diffusion. In cooking, the smell can spread throughout the house, especially in ملوخية. if you know, لو انت بتحب الملوخية، يعني ماما تعمل لك ملوخية بتشم ريحة ملوخية وانت طالع في الاسانسير، حتى بتشمها في الاسانسير. If we put a drop of ink to some water, the color of the ink will spread throughout the water. In liquids and gases, the particles are constantly moving and changing direction as they hit others particles, like this, as we said before, like the perfume particles hit the air particles, and so they spread out everywhere. They move in any direction, they move in a random way. This is called diffusion. The overall direction of the movement is from where the particles are more concentrated, like the perfume particles, to where the particles are less concentrated. Diffusion only occurs in liquid and gases, because liquid particles can move everywhere and gases particles can move everywhere. But in liquids it's very slow, because the particles in liquid move very slow, while the particles in the gas move very fast, because the particles are free to move in these two states of matter, which is liquid and gas. Diffusion in gases is faster than in liquid. Why? Because in gases the particles move rapidly, but in liquids they move slowly. So diffusion does not occur in solids. Why? Because the particles cannot move around in the solid state. Excellent. Going to the last point. Now we are going to the last point. What is the last point? The last point, which is the rate of diffusion. What? The rate of diffusion. Rate of diffusion? Yes. The question now, are all gases diffused by the same speed, by the same rate? This is the question now. Are all the gases diffuse by the same rate? The answer, of course, no. No, yes. Hydrogen diffuse very fast, while carbon dioxide, as example, diffuse very slow. Why? Because the rate of diffusion depends on the MR of the gas. What? The MR. What is the MR of the gas? The relative molecular mass of the gas. In chemistry, hydrogen, its relative mass 1. Carbon, its relative mass 12. Oxygen, its relative mass 16. Nitrogen, its relative mass 14. Chlorine, its relative mass 35.5. This is from the periodic table. This is from the periodic table. And you have a copy in the exam from the periodic table. You are not need to memorize these numbers. Okay. So hydrogen gas, what is the relative molecular mass of hydrogen? Hydrogen 1, 2 hydrogen, يبقى 2 grams. What is the relative mass of gas such as methane, as example? 4 hydrogen 4 times the carbon 12, 16 grams. What is the relative mass of something like NO2, nitrogen dioxide? N14, oxygen 232, 2 plus 4, 6, 3 plus 1, 46 grams. Yes. What is the relative mass, molecular relative mass of carbon dioxide? Carbon 12 plus O2 times 16, 32. 2 plus 2, 4. 3 plus 1, 4. 44 grams. What is the relative molecular mass of HCl, as example? Hydrogen 1 plus chlorine 35.5. Both of them equal 36.5 grams. The question now, when they diffuse, can we rearrange them? Who is or which one of them will be the faster one? Hydrogen number 1, because the hydrogen is very small. Is number 1. What is after hydrogen? Methane number 2. Yes, 16. Then HCl number 3. Yes. Yes. Then carbon dioxide number 4, and this is number 5. And they will be approached to each other because they approximately near to each other from their MR, relative molecular mass. This is number 4 and this is number 5. The one which win in diffusion, hydrogen, and the one which lose, of course, is nitrogen dioxide, because he is the, yes, the slowest one. Hydrogen is the fastest one. Yes. We can make an experiment to know what is meant by diffusion. What is this experiment? Concentrate with me, please. We get a glass tube like this. Concentrate, please. And this experiment based on a chemical reaction, which is when ammonia gas, NH3, reacts with hydrogen chloride gas, HCl, they combine together to form ammonium chloride salt, which is make like white fumes, like the smoke of cigarettes, something like this. عارفين دخان السجاير كده؟ هي حاجة كده يعني. ما تشربهاش طبعا السجاير، عشان السجاير مضرة بالصحة. اهو ammonia plus HCl gives ammonium chloride. ده جاز يس وده جاز يس. ده white fumes called solid لانه بيعمل فعلا white fumes. طيب الاكسبيرمنت دي بنعمل ايه؟ we get a cotton wool here, cotton wool soaked with concentrated ammonia. Concentrated ammonia, yes, NH3. concentrated ammonia, liquid ammonia concentrated. This cotton wool soaked with ammonia. We soaked it with ammonia. We put it in concentrated ammonia solution and put it here in this tube. And we close the tube from this inside by stupor. Stupor, yes. Stupor like this. The other side, we get a cotton wool also soaked with concentrated HCl, which is called hydrochloric acid, HCl concentrated, and a stupor from this part. Stupor here, cotton wool soaked with ammonia. Here is cotton wool soaked with HCl. What about the ammonia particles starts to move? The ammonia N14 plus H 3 times 1, 3. What is the MR of the ammonia? The mass of ammonia, 17 grams. What is the mass of HCl? H1 plus Cl, 35.5. From the periodic table, okay? You don't need to memorize them. There is a copy from the periodic table of the periodic table will given for you in the exam. 1 plus 35.5, 36.5. Who's move faster? Of course, the ammonia molecules. Oh, diffusion. Diffuse fast. Then they will meet what? The HCl. Where the HCl particles starts to move from right to left, but in very small motion, because HCl is fat. They will meet here at this position. Exactly, yes. Forming what? Forming white solid of ammonium chloride, which is approach to the HCl than the ammonia. So this distance is very large distance, more than this. Why? Because the velocity of ammonia is more than the velocity of HCl, or the speed of ammonia faster than the speed of HCl. So they will meet approach to HCl, forming ammonium chloride. What is the rule here? The smaller the MR, the faster the diffusion. The smaller the MR, the faster the diffusion. The smaller the MR, the faster the diffusion. Okay, we can see this experiment, okay? Take care with me, please. Take care with me, please, okay? Okay, look. This is the experiment called the diffusion. This is a glass tube, as I said, okay? This is a cotton wool will soaked with ammonia, and this is a cotton wool will soaked with concentrated HCl. And we will put stupor here and stupor here. The HCl molecules will be diffused from right to left, okay? And the ammonia molecules will be diffused from left to right. Is they will meet here in the middle? No. Here at the left hand side? No. Here at the right hand side? Yes. Because the ammonia molecules diffuse faster than the hydrogen chloride molecules. Okay, okay.
Hydrogen chloride diffusion experiment. Here's some conc HCl. If we place a few milliliters onto the cotton wool down the right hand side, we can close off with a bung. Over on the left hand side, we've got some concentrated ammonia. 2. Close off the tube with a bone. Make sure it's level. And observe.
The ammonia molecules will go from left to right, diffusion, and the hydrogen chloride will be diffused from right to left, diffusion. Look to the molecules of the gas will move from left to right. We can't see the molecules. Yes, of course, we can't see it. And we cannot see the molecules of HCl. But now we start to see when they meet here in this place, forming ammonium chloride. Okay, they start to meet. Look, look, look. Okay, ammonium chloride solid. Oh, nearer to the HCl. Look, the molecules of HCl, very small diffusion. Very
Hopefully you've started to observe some white cloudy material.
White cloud
here.
material, which is ammonium chloride, ammonium chloride, NH4Cl. This.
It's a solid.
Yes.
It's swirling around as a smoke suspended in the air there. What is it?
Ammonium chloride.
How do you explain the formation of the white solid?
Ammonia reacts with HCl, forming ammonium
How do you
chloride.
explain where it forms?
Where it forms near to the HCl, because the HCl molecules diffuse slower, while the ammonia molecules diffuse faster, because the MR of HCl 36.5, while the MR of ammonia 17. The lower the MR, the faster the diffusion.
The ammonia hydrogen chloride diffusion experiment.
Okay. Okay. So speed of diffusion and molecular mass. The smaller the molecular mass, the faster the molecules to move. The faster the molecules to move. So lighter molecules diffuse faster than heavier molecules. This is called diffusion. The ammonia molecules diffuses from left to right, and the HCl diffuses from right to left. They will meet here, forming ammonium chloride. Ammonia NH3 reacts with HCl, forming ammonium chloride NH4Cl. This is gas, yes. This is gas, yes. This is solid, white solid, ammonium chloride, which is this ammonium chloride. When ammonia and hydrogen chloride are diffused and collide with each other, they react and form a white solid, ammonium chloride. The white ring is nearer the hydrogen chloride end of the tube. This shows that ammonia diffuses faster than hydrogen chloride. Look to the MR of ammonia, molecular mass. This is called relative molecular mass. M molecular mass, R relative molecular mass. We will know inshallah what's meant by relative, why we say relative. But even now, take it like this. The mass of ammonia is 17 grams, while the mass of HCl is 36.5 grams. So ammonia faster than HCl. And this is our explanation. In the exam, you will be asked about the position. He says the position, they will meet in A, B, or C. The model answer is C. Give reason for your choice. Explain your choice. I'll say because the diffusion of ammonia is faster than the diffusion of HCl, because the MR of ammonia is 17, which is smaller than the MR of HCl with 36.5. Thanks for your listening. I hope you are enjoying with this lecture or this session. Thank you and wait for the next sessions, inshallah. Thank you. Thank you so much.